Okay, up until now we have been drawing parabolas in a format that we recognise, and we know the shift, amplitude shift, sometimes it's negative. We know sometimes there's a horizontal shift. I'm going to call that plus h squared, and sometimes there is a vertical shift. I'm going to call that plus v for vertical. Okay, so that there is what we're familiar with. We're going to now move away from that and look at equations that are in a different format. For example, y equals bracket x plus 1 close bracket x minus 2, say. Okay, it's still a quadratic equation and it still has a curve that is a parabola. To solve this, or to draw this parabola, we're going to need to find out the x and the y-intercept, or the x-intercepts and the y-intercept, because there's only one y-intercept and there'll be two x-intercepts. Okay, so the method is, what do? Make what? Make y 0. So continuing with my example, I'm just going to make y 0 here. And solve. What are the two solutions? X equals negative 1 and 2. Okay, hopefully you remember that from algebra. When you put negative 1 in for x, you get minus 1 plus 1, that gives 0. When you multiply 0 out with anything else, the whole equation works towards 0. If you put 2 into this bracket, 2 minus 2 becomes 0, 0 multiplied by anything else, the whole bracket becomes 0. So my two solutions are x minus 1 and x2. So on a Cartesian axis, those two positions are at minus 1 and positive 2. This is going to be a sketch, not a drawing. The turning point for this parabola is going, remember parabolas are symmetrical. Okay, they have a mirror line. And the mirror line will be at this point here. Now remember, this is 2, this is minus 1. What is halfway between positive 2 and minus 1? A half. Okay, so when x equals a half, we can work out the coordinate, the corresponding coordinate to x equals a half. I've just gone halfway between minus 1 and 2, and that becomes half. So when I put half into the equation, a half plus 1 multiplied by half minus 2. So that's going to become 1.5 multiplied by minus 1.5. What's 1.5 times 1.5? Two and a quarter. Is that right? The answer is negative because it's a positive times a negative. So down here at negative 2 and a quarter is another coordinate. So far I've got 3 coordinates, the x-intercepts, the turning point, and I'm going to find one last coordinate to draw my parabola. What do you think my last coordinate's going to be? The y-intercept. The y-intercept is found by... Yep. To find the y-intercept, put x equal to 0 this time. Here's the equation. Bracket 0 plus 1, close bracket 0 minus 2. What's 1 times minus 2? Negative 2. That is where it cuts the y-axis, and if you look here on the graph, there's negative 2. And it should make sense. It does make sense because the turning point is slightly lower than where it cuts the y-axis. Okay, and there's my parabola. This doesn't have to be a standard parabola, i.e. cross 1, up 1, cross 2, although it usually is. It doesn't have to be. Examiners will be looking for 4 points done correctly. Y-intercepts, y-axis, y-intercept, x-intercepts, and the turning point. Okay, so you should be looking to get all those 4 points exactly right. It's no, you could, if it's easy, just put those points in. Actually, this is not a standard one, is it? It doesn't go across 1, up 1. I might do. I'd have to draw it out with a grid and see. Should we do that? I'll do it in a minute. Okay. If I look at, I'm looking on page 122 and look at question 3, for example. There is one step that I haven't shown you, but you know how to do, and that is to factorise first. So question 3, page 122. Looks like this. Draw this graph. Y equals x squared minus 3x minus 10. Okay, first step is to be able to do this. Factors of 10. 5 and 2, that'll do. 5 and 2 have a difference of 3, so I'm happy with those two. Where does... There has to be a negative, one of them has to be negative. It is minus 5, and the reason it's minus 5 is because minus 5 plus 2 gives minus 3. So that there is correctly factorised. Okay, so then from here on in it's the same pattern. The x-intercepts. Minus 2 and what? And positive 5. Because, remember, we made this equation 0. So minus 2 goes there. Positive 5 goes there. What's the next step? I found the x-intercepts. What's the next step? Okay, we'll do that one first. Find the y-intercept. Make what? Make x 0. By the way, we could use the top, this one, for making x 0 in. Okay, so if I do that, 0 squared minus 3 times 0 minus 10. It's the y-intercept. Just check that it works in this one as well. It does. 2 times minus 5 is minus 10, so I'd get the same answer in both equations. It's a good thing. And what was the third point that we want to be able to plot? Someone else. So we've got two x-intercepts, a y-intercept, and what's the third point that we want to... The turning point. Right, so the turning point, I'm going to guess, is somewhere down here, but we need to identify it as what's halfway between minus 2 and positive 5? One and a half. Now, if you weren't sure how to do that, I'll tell you how you do it. You add the 2, you add the 5 and you add the 2 together and you divide by 2. So it's literally, this is how you do it. x1 plus x2 over 2. And in our case, so I'll just call this midpoint. In our case, it was 5 plus minus 2 over 2, which is 1.5. So at 1.5, I need to find the y value. I'm going to use this equation, although I could use the top one as well. I'm going to use the factorised version. Whoops. What happened? Deleted. So I'm going to put 1.5 plus 2 multiplied by 1.5 minus 5. Answer 3.5 multiplied by 3.5. Can someone help me out here? 3.5 times 3.5? There we go, 12.25. So this value here, it's negative. $12.25. Okay, so now I've got 4 points, and they look like a parabola, so you'll know you made a mistake pretty quickly if... Oh, by the way, because you can easily get another point here because of symmetry. If this at minus 10 is 1.5 to the left, at another 1.5, i.e. at 3, there should also be another 10 because of symmetry.